Okay, in this video, we're going to go through some additional practice now that we've gotten more comfortable with properties and rules of logarithms. So the first thing I want you to do is, I notice there's a typo in this problem. Change this base 4. We're going to rewrite that as base 7. That's a typo. And in this question, they're defining log base 7 of 8 as A and log base 7 of 4 as B. And the question is asking us to rewrite this expression so that it only is written in terms of A's and B's. So I'm going to use my rules of logarithms to expand this expression and then substitute in my values for A and B. So because this is a quotient, I can rewrite log base 7 of 8 divided by 4 as log base 7, 8, minus log base 7, 4. And since in the problem it tells us that log base 7 of 8 is A, I'm going to rewrite this as A. And it also tells us that log base 7 of 4 is B. Here's my final answer. So we've written this expression, log base 7 of 8 over 4, in terms of A and B based on how they defined A and B. Okay, example 2, it says use the properties of logarithms to evaluate without using a calculator. So without using a calculator, we just have to be comfortable with our exponent rules and our math facts. And so what I'm going to do is I'm going to look at this and try to decide what that exponent would be. Remember, logarithms are exponents. So what this log base 3 of 1/9 is asking me is, what exponent would I need to raise 3 to in order to get 1/9? Well, if I take 3 and square it, that gives me 9. But in order to have an exponent that flips my fraction upside down and makes it the reciprocal, it would have to be a negative exponent. So log base 3 of 1/9 would have to be equal to negative 2. Because if I take 3 and raise it to the negative 2 power, that would give me 1/9. Now I'm going to figure out what log base 3 of 3 is. So log base 3 of 3 is asking me, what does my exponent need to be? If I take 3 to what power to give me 3? It would have to be 1. 3 to the first power would give me 3. So now I can clean this up. I have minus 2, minus 3, and my final answer would be minus 5. Okay, in this example here, I need to figure out what log base 8 of 2 is. So that's asking me 8 raised to what power would give me 2? Well, the cubed root of 8 is 2. And if I write the cubed root as an exponent, that would have to be 1/3. So 8 raised to the 1/3 power would give me 2. So log base 8 of 2 is 1/3. Okay, so now I'm going to try to figure out what log base 8 of 64 is. 8 raised to what power gives me 64? It would have to be 2. 8 squared is 64. So the top is 2. And then in the denominator, I have log base 8 of 4. Now, what we can do, actually, to make this easier, is I'm going to bring that 3 up in front of the 4 and use my power rule. So I'm going to write this as log 8 of 4 to the 3rd. I'm going to carry this down and clean this up a little bit. 12 times 1/3 is 4. Now log base 8, 4 to the third. 4 to the third is 64. So this is log base 8 of 64. Because this, 4 to the third, is equal to 64. So now I have 4 plus, and this is now going to be 2 over 2 because 8 squared gives me 64. So log base 8 of 64 is 2. So this gives me 4 plus 1, and my final answer is 5. Okay, last example. Okay, so we have 4, and I've got to figure out log base 4 of 2. Well, to go from 4 to 2, I would have to raise 4 to the 1/2 power because the square root of 4 is 2. So log base 4 of 2 would have to be 1/2. And so I have minus 2 times 1/2 for this one as well because log base 4 of 2 is 1/2. Okay, so this would give me 4 times 1/2 would give me 2. Minus 2 times 1/2 would give me 1. And then 4 raised to what power? If I want to figure out what this is equal to, log base 4 of 1 over 64, I know 4 to the third is 64. And if I want it to flip upside down and the fraction to be reciprocated, I would have to make that exponent a negative. So this, log base 4 of 1 over 64, has to be equal to -3. So I have 2 minus 1, which would be 1, and then a 1 and a -3 would give me a -2. So -2 would be my final answer.